Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you with homework problems 1, 2, 3 in Unit 2 here. So the first one, it says the mass of a certain elephant is 5467 kilograms. I don't have an elephant here to bring up. If you'll humor me, I think I'll approximate that elephant as a T-Rex. So, alright, so here's our elephant, if you will. And the mass of this elephant is given. Mass is 5467 kilograms. Now, you may be looking at different numbers because the way I set up my online system, I set it up in such a way that everybody has different values, but we're going to talk about this example using my numbers, the 5467 kilograms here. And part A says to find the elephant's weight in newtons. So that's just a simple calculation. The weight of an object, or what we call the gravitational force, is equal to mg. And again, this is an F sub g here. That is an F times g. I meant that as the gravitational force acting on an object is mg. The mass is given in the problem. The value for g is 9.8 meter per second squared, or meter per second, and this is just a matter of putting in the numbers and getting a number out. All right, part B, where it says to express this weight in pounds. This is a unit conversion, so you're going to have to look up how many, either how many pounds per newton or how many newtons per pound. I believe, although I don't want to be quoted on this, I want everybody to look this up themselves, but I think, if I remember right, it's 5.2 newtons is equal to 1 pound. So you're going to use this as a unit conversion, and you're just going to take your answer to A in newtons and convert it to pounds. All right, that's pretty well all there is to number one. Let's chat about number two. I got to clear my screen to do so. All right, in number two, it says a motorcycle rider has a mass of 335 kilograms. The rider applies the brakes, causing it to accelerate at a rate of -6 meters per second squared. So there's a mass given in the problem. In my example, it's 335 kilograms. There's an acceleration given of -6 meters per second squared. In my example, yours might be slightly different. First, we should probably chat about this minus sign here. Now, when we talk about plus and minus signs on vectors, when I ask people about what that minus sign means, 95 out of every 100 people would say that it means it's slowing down. And that's not technically correct. It is possible, in fact, it's really easy to have an acceleration which is considered negative and still have an object speeding up. What they mean by this is that the acceleration is opposite of the direction of the velocity. So I'm going to go ahead and use this fellow here as my model here. So imagine this motorcycle, if you will, is driving along, and the velocity vector is in this direction. Okay. If he were accelerating this way, it means that this vector would be getting bigger and the motorcycle would be moving faster. Acceleration in the opposite direction means that your velocity here is decreasing. And the net effect in this problem is it is slowing down. But I'll probably make more videos about the subtleties about pluses and minuses with velocity and acceleration vectors. But for now, I'll just say this. This minus sign means opposite of the velocity direction, which in this example will mean he will be slowing down. And it says, what is the net force on the motorcycle? So that's just a Newton's second law problem. Start by writing out Newton's second law. Net force equals mass times acceleration. And the mass is given in the problem. The acceleration also given in the problem. Just put those numbers in as you see them. I would include the sign. You're going to get then a negative number for the force vector, but in the computer system that we use, I'm pretty sure that's what they're looking for. They're either looking for a negative number, or you'll see a spot to put the magnitude where you're going to put just the value and not include the minus sign, and the force is in the opposite direction of the velocity. So that's probably enough for number two. Let's chat about number three. All right, so it says, in an experiment performed on a space station, a force of 44 newtons causes an object to accelerate at about 6 meters per second. What's the object's mass? So there's some sort of object. I guess I'm not going to bother with a model. I'm just going to say there's my object. And we know that this object in this problem, I guess we don't know the mass, so I'll go ahead and label that as an unknown. We know that some sort of force applied to it. I don't know the direction, and it's not important for the direction or for this problem. Causes it to accelerate at a value given in the problem of 6 meters per second squared. This is just a standard Newton's second law problem, so I'll go ahead and write out Newton's second law. Net force equals mass times acceleration. And there is our net force, and there is our acceleration, and that will allow you to find the mass. So that's enough on problem number 3. I'm going to call that done. And in the interest of keeping these videos kind of short, I'm going to stop that there and just start a new one. I hope that this helps you get your homework done. Have a great day.